Hey guys, what is up? So hopefully you guys were able to fill out the unit circle with the degrees and the radian measure, okay? We'd already come up with 180 degrees was equal to pi radians. Half of that, 90 degrees, was equal to half of pi radians, right? What about this one here, if it was 30 degrees, right? Well, how does 30 compare to 180? Okay, well 30 is 1/6 of 180, isn't it? Right, 30 times 6. So wouldn't the radian measure be 1/6 of pi? How do you write that? You write it pi over 6 radians, okay? All right, so today what we're going to do is learn how to, or in this video rather, we're going to learn how to fill out the coordinates that go around the circle, okay? So what you're going to need is another circle. So go ahead and grab a, I don't know, something like this maybe that helps you draw a circle, or maybe a coffee cup, okay? Ooh, there's still some coffee. Yummy. All right. So what we're going to do is try to come up with the coordinates for, let's just do this point right here. We want the coordinates for that point and the coordinates for this point right here. And then from there, I'm confident you guys will be able to come up with the other coordinates, okay? All right, so think about this. This is a unit circle, okay? Which means that the radius is 1 unit. That's what the unit circle means, okay? It's 1 unit radius, all right? So watch this. If I was to come up with the coordinate for this point right here at 0 degrees, well, isn't that x comma y? Well, how far out did I go in the x direction? That's right, 1, okay? And how far up did I go? I didn't, so 1 comma 0. Can you do this point right here? Can you do that point? All right. All right, what is that guy? Well, how far to the right did I go? 0, okay. How far up did I go? Well, the radius is 1 here, so what's the radius here? That's right, it's still 1, isn't it? Okay, so 0 comma 1. All right, so what we're going to try to do is come up with the coordinates for this point first, okay? So what I'm going to do is draw a triangle, okay? Now remember, it's this section right here, okay? But I'm not going to draw that section. I'm going to draw a right triangle that fits into that section, okay? So here's the triangle that I'm going to draw, okay? So here's one thing that I'm going to do. I'm just going to draw this triangle, okay? So if you notice, this right here is this point right here, okay? This right here is this point right here, okay? So let me ask you one thing. Can you tell me the length from here to here? Well, what's the length from here to here? What do we call that distance? That's right, it's called the radius. What's the radius? It's 1. So the distance from here to here is just 1, isn't it? Okay. All right, now let me ask you this. What is the measure of this angle right here? What is the measure of that angle right there? I hope you said 30 because that's what we said. It's a 30-degree angle. That's why I put the 30 right there, just to let you know that this line right here cuts out a 30-degree angle right here, okay? So if you see the 30 there, that means this angle's 30. So that means that this angle right here is 30, okay? All right, now let me show you something really quick, all right? If this is a 30-degree angle, all right, let's just say I double this really quick, okay? Okay. Now let's just do a little math, okay? We've done this before, okay? You've done this before. I'm not going to get into trig or anything like that, just regular geometry. What kind of an angle is this? I told you this is a right angle, right? So this has got to be 90 degrees, okay? So if this is 90 and this is 30, what's the measure of this angle right here? What's the measure of that angle right there? If this is 90 and that's 30, that's 120. How much do all of the angles add up to? Okay, that's right, they add up to 180 degrees. So what's left here? 30 plus 90 is 120, plus how much more? That's right, 60, okay? Now if I flip this, if I reflected it like this, then this angle's got to be 60 and this angle's got to be 30, which means that this guy right here is 60, which makes this what kind of a triangle? That's right, it makes it an equilateral. So if this side is 1, what's this side right here? What's also got to be 1? okay? And this side right here is 1 as well. This is an equilateral triangle, 60, 60, and 60. So if this side is 1, then this side's 1, and so is this side. So if this side is 1, what happens if I erase this part again? Okay, then what would this piece be right here? That's right, it would be 1/2. Half of 1, right? Okay, and now we just need to figure out what this guy is right there. Okay, well, Pythagorean theorem says the leg squared plus the leg squared equals the hypotenuse squared. So we know that 1/2 squared plus question mark squared, right, equals the hypotenuse squared, so 1 squared. This is 1/4, okay, plus, let's just call it x squared, equals, this is 1, okay. Subtract that to the other side, you get x squared equals 1 take away 1/4 is 3/4, right? Okay. Take the square root on both sides. So x equals the square root of 3, okay, over the square root of 4 is 2, and that's the length right there. This is the square root of 3 over 2. That's the length of that side. So, knowing that, can you fill out these coordinates for the 30-degree angle? Okay, how far over did I go? That's the x direction. And how far up did I go? That's the y direction. Well, how far over did I go? Radical 3 over 2. So this guy right here is radical 3 over 2. How far up did I go to get to that point? 1/2. Boom. Okay. Can you figure out the coordinates for the 60-degree angle? It's kind of like this guy, only flipped up to there. I'll let you figure that out. Okay. Now let's figure out the coordinates for this 45-degree angle. Okay. So this is how we do it. All right. So let me sketch the 45-degree triangle. It's from this pie shape right here, but I'm just going to sketch a 45-degree triangle right there. Sorry, 45, 45, 90. If I could slow down for 2 seconds. So let me just sketch that really quick. Okay. I'm going to sketch a 45, 45, 90. Okay. There's my 45, 45, 90. Okay, right? And the reason I'm saying that is because, remember, this is 45, so that means this angle right here is 45 degrees. So here's my 45 degrees, okay? It is a right triangle that I'm throwing in there, okay? 45 plus 90 is 135, plus another 45 to give me my 180, okay? There's my 180 degrees, all right? Notice this point right here is this point right here in the center. Notice this point right here is this point right here, okay? Well, what's the distance from here to here? Isn't that a radius from the center to the circumference or the edge of the circle? Okay, so what's the distance from here to here? Well, it's 1. All right, good. And if you remember anything about a 45, 45, 90 triangle, you know that it is isosceles, which means that this guy right here is the same as this guy right here. Okay, that's how isosceles triangles work. If the base angles are the same, then these two sides are going to be the same. And using the Pythagorean theorem again, we know that leg squared plus leg squared equals hypotenuse squared. So x squared plus x squared equals hypotenuse squared. How many of these do we have? We have 2 of them. So 2 of the x squareds equals 1. Divide by 2, so x squared equals 1/2. Take the square root on both sides, so x equals, the square root of 1 is 1, over the square root of 2 is the square root of 2. Now, let's rationalize that. So this is going to be multiplied by square root of 2, square root of 2. So x equals square root of 2 over, that turns into 2. So this guy right here is square root of 2 over 2. And this guy right here is square root of 2 over 2. So to get these coordinates, can you do it now? How far over do I have to go to here, and then how far up do I have to go? Well, I have to go over rad 2 over 2. And then I have to go up rad 2 over 2. And that's how you do it, okay? And your challenge is to finish the rest of it, okay? Your challenge is to do all of them. Ooh, boy. Can you do it? I think so. All right. Love you guys. Bye.